All right. Good afternoon, everybody. Hopefully you can hear me, see my screen. If not, we have a questions section right in the GoToMeeting. So I guess if no one can hear me, that's not going to do too much good. But at any point in today's presentation, if you do have a question, feel free to ask it. I have it open on my other screen, so I will get to them as I'm going through today's topic, which is mates. So if this is your first Lunch and Learn, welcome. Thanks for joining. If I see a couple regulars on the list here, so thanks for coming back. And hopefully I can teach you something new about mates. So jumping right in, what we'll be looking at today, first topic is going to be smart mates. So when you're in an assembly, how can we quickly combine some stuff together, constrain items, and do simple mates without needing to do 4 or 5 button clicks to get that mate accomplished. So we'll be looking at a slew of these ones and how we accomplish them. And then going to look at copy with mates. So how can we reuse information we've already given SolidWorks and reapply it to similar parts or identical parts. We'll jump into multiple mate mode. So how can we use similar geometry across a project and apply it to many parts inside an assembly. And then I'm going to go through the options that come with advanced mates. A couple of these look new from 2015, so we'll go through that. But we'll do a profile mate, symmetrical mate, width and path, and then look at linear coupling and some limit mates, and just talk about how those are going to apply into your assembly. All right, so without further delay, we'll jump right into some smart mates. Here are the options that we have for smart mates, and you can see the project that I'm going to be working with completed. I'm going to go through how to create these types of mates, and when I'm selecting entities, keep your eye out on my mouse or my cursor, because that's going to change and tell me which type of mate or smart mate I'm creating as I go through this. So as I grab 2 edges, I'm going to have a coincident mate on those edges. As I grab 2 faces, I'm going to have a coincident mate to put those planes flush together. So we'll go right through this list. I'm going to open up SolidWorks here and start with my first project. So like I said, we have our finished project over here, and that's what we're going to end up getting to. And the first mate or smart mate I'm going to use is actually the last one here, and it's origins and coordinate systems. So currently I have all my coordinates and origins turned on. So my visibility, I just set them up here. So I'm viewing my origins. Now, whenever I go into an assembly, typically your first part is fixed, but it doesn't always mean that it's fixed on an assembly. So what I did here was float my first part in my assembly. And instead of coming through and saying, all right, I want this fixed on the origin, first I'm going to have to go to my mates, and I want it on my front plane and match it here, and then I want my right plane and match it here. Instead of giving that 3 separate mates, what I can do is select my origin here and hold down my Alt key with that selected. So the Alt key is your trigger for your smart mate. So as I'm coming closer and closer to my origin, you'll notice it's very small and kind of tough to see. Let me see if I can get a bit better angle here. So as I zoom in, I'm going to drag it, and I have my paper clip, so that's showing me that my mate is initiated on my cursor. And once I hover over this, I get my coordinate system to coordinate system smart mate identified. So now all I have to do is let go of Alt and my mouse button, and I get a couple options here. My normal pop-up for my mate, even though my mate command isn't initiated. So one of the options is to align my axes. So instead of doing those 3 mates on top, front, and right, I can just align it with the current coordinate system that's in this project. Go ahead and accept it. And now this guy's locked down. You can see that it's fully defined as I try to move it. So it's a real quick drag. So holding Alt and dragging is going to fully define this part for me. And you'll notice that I do get a coincident mate under my mates. So I never had to go into my paperclip. but I'm already creating mates inside my assembly. The next one I want to look at here is I'm going to use this top cover and do a different type of smart mate. Oops. Not do a sketch. Do a different type of smart mate here. So I'm going to grab the edge of my top cover. I'm going to hold down Alt, and now I'm going to drag it to the edge of my base. Again, you'll see that my cursor changes. I can see that I have an edge-to-edge smart mate happening. And if I don't think that it's the correct mate as I want to flip it, I can hit the Tab key, and that's going to give me my alternate variations for this part. So this one, as I'm moving it around, I can try to line it up, and that looks pretty good right there. And then all I have to do is let go of my mouse button. Actually, I missed that one. So click here, Alt, drag, verify my mate's there, and let go. All right, so now I have a coincident mate for this. Say OK. And now I can see that we're good here, that this is actually stuck to one another. So that looks good. Rotating that. That's why I got it to the face, not to the edge. So that's not really the best mate for me there. So I'm going to delete that one out. Give it one more go here. I'm going to zoom in close, grab this edge, hold down Alt, grab my other edge. Got an edge-to-edge connection. That's what I was looking for. Now I'm happy. Okay. So what else can I do with the simple hold down Alt and drag? One thing I can do is go vertex to vertex. So if I want to grab this point, hold down Alt and drag to this point, you'll see that I get a point-to-point connection showing up on my cursor. Let go. It comes in as coincident. Go ahead and hit OK. Now I'm almost fully defined here. I got one more thing I need to do. And this time I'm going to go concentric to concentric. So I'm going to click on the inside of my through hole here, hold down Alt, hover, and you'll notice that the part that I'm sliding or trying to mate to goes a little transparent for me so I can actually see the holes I'm trying to combine with. And this time my cursor shows me that I'm creating a coincident mate. I can go ahead and drop that. It still gives me the options after I do that. So I still have my flyout for my mate screen. So I can always make them parallel or tangent depending on what I need. But SolidWorks does a pretty good job guessing of what you're trying to do based on the two selections in your mate. So I'm going to hit concentric, hit my green check. Now this guy's fully defined. Alrighty. What else can I do with my smart mates here? So my offset shaft here, I want to go through this. Old way of doing this, I could always initiate my mates, click on this, click inside this, make sure they're coincident. Then I can grab an edge, grab a face, and have them snap together. Two mates pretty quickly if I use my my mouse gestures to get to my mates and a couple points and clicks. However, I'm going to show you a quicker way to do this using some smart mates. I'm going to delete those last two mates that I had and grab this guy out. So one of the smart mates that we can initiate is called a peg and hole. And it's a pretty generic mate, knowing that for most of the time we're trying to put a screw into a hole. We're trying to put a pipe through another hole. It's typically a hole. So for a peg and hole relationship, what SolidWorks is going to look for is an edge from your first mate, and then an Alt drag, and then it's just going to look for a hole that you're trying to put it into. So you'll see my symbol now, instead of being concentric or point to point or edge to edge, we now have a peg and hole symbol, which I can always flip around in case it doesn't look right, and that's, again, using the Tab key. I can alternate between the direction of my mate, but that looks good there. And you'll notice what it did for me is automatically put those last two concentric and coincident mates that I deleted earlier. It does it automatically for me, and I can keep my rotation here. So it's a simple drag and drop now, and it's going to generate 2 mates that I needed versus going through my mate menu and trying to pick and choose faces and edges. So a real quick way to get that to snap into place. All right, got another one here. So this guy I want to mate to the front of my base. You'll notice that I have a couple hole patterns here. So if I come into my round cover, we'll see that I have a circular pattern for these holes that match my circular pattern for my base. So when I do this, I'm going to select the edge because I want a version of a peg and hole here. I'm going to hold down Alt and come to the outside edge of this. So now what I have the ability to do is snap both to the face, but also to match up my hole pattern. Angle it correctly. There we go. So SolidWorks is finding the pattern, knowing that for this peg and hole, we're going to need to line the flange up with its through holes all the way around the system, and it's going to drop everything in for me automatically. So I'm now fully defined where I would typically need 3 mates there. One simple drag and drop, holding down the Alt keys, giving me all 3 mates. So a nice quick way to do, turn these off real quick, do some mating, and I filled up my mate tree here, but you haven't really seen me go into assembly, mate, and start selecting which type of standard mate I want to use. Everything was done using that Smart Mate feature. Cool. I think I hit through all of these ones. Had my concentric, had a point-to-point using 2 vertices, and then the peg and hole one was that super convenient one that's going to line up both flanges for Smart Mates or allow some rotation like we had for this offset shaft. All right, so now you're going to go into copy with mates. It's another function that's in standard SolidWorks and a huge time saver if you can apply it correctly. So looking at the model I have, we had our circular flange that I just attached. Now I want to copy it to the other side. Jump back into SolidWorks here. So I'm looking at my flange. I didn't end up using this guy. I'm just going to delete him. Yep. All right. So I didn't end up, or I want to bring the exact same part over to this side. Again, I can do it kind of the long way. I can search for that part out here, grab it, bring it in, redo my mates, even do a Smart Mate. However, a quicker way to do that, because I don't want to insert, is just to right-click on the part that I'm looking to replicate, and I have a Copy with Mates option here. I'm going to turn that on. And the first menu we see is the type of, or the part that you want to copy. So for this one, it's going to be my round cover, and that looks good. And again, SolidWorks gives you the heads up to say, yep, select the component you want to copy. Did that. Now I'm going to hit my next arrow up here that's kind of hidden. What the next arrow does is gives us new reference points for where we're going to apply this part inside our assembly. So the first one, and I will highlight it in orange for the part that you're, or the new part where you're placing it, and purple is where it's currently placed, so the current mate that exists, the current reference that exists. So this was the outside edge of my flange, was concentric to the outside edge of my base. So really what I want here is the same mate. I'm going to remain concentric to this circle because it's a symmetrical part. So what I can do is select Repeat. And that's going to steal the face that I already had for the modified housing, because it's concentric mate, it's still going to apply. So the next one, however, is not going to apply as well. So I have the upper left through hole of my flange was my mate reference. However, I don't want that to be the same on this side. So I'm just going to select a new through hole. And we can start to see our transparent part coming through now. And the last one I had is coincident to the front of my base. So this one I have to select a new one because now I'm on this side of my part. Now I've selected all three components. Looks pretty good. You'll notice that it's not a mirror based on this thing because I selected a different through hole on this side. So I can spin this part as much as I need because I'm selecting three new mates, or three new reference points for these mates. So that looks good. SolidWorks gives me the green OK that it has been placed. It's fully defined. I can hit check. This actually, copy with mates, will trigger another session. So if you're trying to do 10 of these mates in a row, this screen on the left side will stay open until you hit the red X. And then it will knock you out of that. So now we can see that I have identical parts without needing to go through and actually insert a part or reinitiate my mate command. All I'm doing is reusing reference points. And still, at any point, I'm not tied down to any of those. So at any point, if I need to change one of these mates, I can always come back and do an edit. So if I ended up needing to go through this, I can always just rotate that around quickly, hit OK, we're good to go. So you never lock down, which I'm sure you're used to in SolidWorks, that you can always go back, make a change, and update accordingly. All right, multiple mate mode. This was a new one that I found out while prepping for this lunch and learn today. So really, no introduction really. I'm going to come in, launch a new assembly here, and we have a little rocket launcher toy that we're going to create. And I have a 6-part assembly, pretty basic. Everything's floating around. My base is fixed. And what I need to do is have everything assembled based on this base tube. So all these parts are going to fit together inside of here. And it's going to end up requiring probably a dozen or so mates to get this all to function correctly. I want to speed up that process, though. So I'm going to use what's called the multiple mate tool. And it hides right inside our mate menu. So from our mate, we're used to seeing this screen. But hidden in here is this little lightning bolt from multiple mate mode. And now what changes is we're looking for a common reference point. So what do all these subparts tie into for this mass mate? So for our case, it's going to be the inside of this main body, so this tube here. And now it's asking, what do you want to mate this to? And I can select every cylinder that's going to be concentric. And it gives me the option if I want concentric or tangent. But for this case, I do want concentric to that part. And I can just keep selecting part after part. This one, grab this one. And it's going to line up everything concentric to that main selection. So my first entity that I'm mating to. And for this one, I'm going to create a multi-mate folder. And I'll show you what that means in a second. As I'm looking at this, and I can slide some items around. That one. So I'm going to accept this, and now I can slide my items around and see that it's pretty close to what I want, but not really perfect yet. So I'm still always going to need to add my other mates to get this locked down, but for this one, my launcher nozzle here, I can tell that it's backwards. So I can either go back into my multiple mate, find my nozzle, and then just give it a flip. So I can do it that way, or if I need to flip anything and I'm outside my mate command and I realize that, oh, I screwed up somewhere, I can always left-click, use my pop-up menu, and go to View Mates. So View Mates will give you the option to select the mates that are applied to that part, and you can always flip it right here. So, tough one to see. That one's flipping back and forth. Let me grab a better one. So this ring here, we'll go to View Mates. Currently it's only concentric. That's the one I want to change. So I can go ahead and give it a flip, and you can see that my orientation changes based on that setting. Again, the X will clear out of that command. All right, so now a couple other mates that I want to add And I'm going to use Smart Mates for this, so select, hold down Alt. There we go. Get them concentric. Now they're going to move together. Maybe we'll throw just a quick mate here, so those are connected. Slide this up, and we'll do one more. Nope, that's not the edge. I want the face. Yeah, coincident. Face to face. And we'll get those to lock down. All right, so that's enough to at least start to see where my body is all coming from. Clear out of my mate command. And I was saying that I created a folder for this one. So as I come down into my mates, I have those three that I just did, the quick concentric and coincident ones, to finish up my assembly. What I also have now is a grouping, and it's called multi-mates. And as I can come in and see, it has each of those concentric mates that was done on a single command. So everything gets lumped in together. If we didn't want to do that, we can always edit our feature and turn off our multi-mate folder. What's nice about this, though, is if you have dimensions that are tying these down, so if you have some distance mates incorporated already, you can always link them back into your mate folder, and then everything moves and travels together. All right, so my gun is now half done. What I'm going to do this time is still do a copy with mates. Now I'm going to show you that we can select more than just one part that we want to copy. I'm going to take my nozzle, my plunger, and my ring here. I'm going to take them all, hit my next arrow, and now we have all mates that we have done so far connected to this entire assembly. So the first one, and again, it highlights what we're trying to look for here, is a concentric, and that was along our base. Again, concentric along the base. Again, so this is going through that entire multi-mate. They're all concentric around there. So that looks good. And now we have our coincident ones. So the first one was coincident along the back plane here. And because this connects, I can repeat this one, and it's going to know where that mate belongs. For this one, I just need to select the front face, and that's going to snap to it. SolidWorks will give me the green OK that everything has been placed properly. Go ahead and hit my check mark, hit my red X to stop doing those commands. And now I have a quickly completed assembly reusing all the information I had already given it. So you can see where this is valuable if you have maybe an array of parts that you're trying to populate. You can quickly do the mates once using some smart mates and regular mates, and then copy all those settings to each of the next spots in the array. That was multiple mate mode. All right, so now for advanced mates. We've pretty much gone through, just want to verify that we've gone through our standard mates. Distance and perpendicular, actually I'll launch those real quick. So this is going to be our next assembly, but I'll finish up with those basic mates just so we know for any beginners out there what we're talking about for these mates. So perpendicular mate, we'll take two faces, not a plane, two faces, and throw a 90-degree angle at them. You still have two range of motion, but that's always going to be locked down. But those two faces are perpendicular. What else do we got? Clear those. Tangent is for a round part and a flat part. Initiate that. So this face, this round face, to this flat face, as they go tangent, we'll accept that. We'll notice that these are going to stay connected together based on their tangency. Concentric we were playing with. Distant mate, I guess, is the last big one. It's going to be between any two objects and you can provide a spacing between those. You can always flip your alignment based on this mate alignment command. So do you want them facing the same way? Do you want to face them the opposite way? And then you can flip your dimension based on the direction of the distance that you want to go. That'll wrap up some of our standard mates. Just going to get rid of that tangency. Yep. All right. So for our advanced mate, the first one we're going to look at is a profile center mate, which is fairly new. And what this is going to do is automatically align geometric profiles. So anything, so any polygon that has a closed edge, a circle, a square, any two shapes that will have a center of mass. So this kind of prohibits any odd-formed shapes, like a U shape wouldn't work here. But we can always make a sketch of a square and use that as our center plane, or our profile center. I'm going to jump back into SolidWorks here. I was showing you coincident earlier, but I'm just going to show you a quick way to mate two squares in this instance using our profile center. So I want this base and this base. I'm going to want them rotated. And my mate alignment, I want them on top of each other. So quickly here, we're pretty much doing like a with mate with a couple concentric mates, but it's only one command. So as I spin this around, I can get the layout that I'm looking for. Everything's going to be locked down. So when I hit my green check, these are now combined parts, but it's a single mate versus trying to do face-to-face, face-to-face here, and then coincident to coincident on the backs. Typically, you'd need 3 mates to lock this part down, where now I'm down to a single one, and I'm only selecting 2 faces. So it's a real quick mate to get stuff into position. We can also look at this, seeing that those were the same size. We can see how this would work for something of different size. I'm going to select profile again. All it's looking for is 2 selections. So I'm going to select this edge, and an edge will create a loop for us. So it's going to find the center of this loop, and then this face, and it's going to lock it down right to the middle of that. And I can always add some rotation here. So we'll recalculate, find the center of that profile, and put them right on top of one another. So pretty cool tool to lock components into place quickly. All right, symmetry mate is going to force 2 entities on either side of a plane, pretty much. It doesn't have to be a predefined plane. It can be a face or a surface, and it's going to put components on either side of that, move them together. So very similar of how we would use a symmetry line in sketching. It's that, but now we're looking at parts. And it's a little bit different than mirroring, because it's only worried about the single distance away from the plane. I'll show you what I mean in a second here. Jump back into SolidWorks. Now this part, I want to be symmetrical in my origin. So I'm going to go into my mate command, select advanced mates, and this time symmetric. So our interface up here now is going to look for a plane and then 2 faces to end, or 2 faces of any parts to mate it to. So I want my right plane. Now this face, and this is a separate part, but it doesn't really matter because they're linked together in this face, and that will make it symmetric on that plane. Looks good. I'm going to do that one more time. This time on my front plane. That face. Cool. So now I'm locked into the middle of my coordinate system here. I'm going to do one more mate just to lock it down, and I'm going to go back to my standard mates and say just stick you to the top plane. Be done. So that gives us a symmetrical alignment for this part. I'm going to clear off, get out of my mates, and I'm just going to hide these planes now that I'm symmetrical there. I'm going to look at these two rings now. So I want these two rings to move symmetrically across this track. The first thing I need to do to get them set up is get them actually centered on the track. So I'm going to just put a quick coincident mate here as I hit this guy. So I'll make them coincident. That looks pretty good. All right. So now we can start to see that these guys are moving together side by side because of that coincident mate. But I can still go this way without any interaction on this one. I'm going to, now that I hit my plane, I'm going to bring it back up. This is my right-hand plane. All right. So with these two being coincident, I can still spin them around. I want them symmetric on this plane. So what I'm trying to do is have them both on this track, but not overlapping. So I'm going to bring in my mates, go to Advanced Mate, select Symmetric. So my plane for this one is going to be the right plane. And now my faces that I'm dealing with are both inside faces. So this inside face of part 1, this inside face of part 2. You'll see that I line up symmetrically now. Hit OK. And now my motion is tied together. So because I'm concentric, I'm moving side to side. And as I move in and out, it's mirroring directly. Now I have a relationship between these two based on the symmetry of my right plane. Real quick though, if I just suppress my concentric mate, we can see that I still have my symmetry going towards my right plane, but as I move this one up and down, I'm no longer concentric. So my characteristic is only in that single axis. My other two, I'm still free to move. Just a note there. All right, width mate. Width mate is going to constrain a tab between two planar faces. So we're going to have two outside edges, two inside edges, and keep them constrained inside the box pretty much. So for these, because I want them on my track, I want them to be inside of here. So the first thing I'm going to do is a quick coincident mate to that. Say OK. So now I'm at least moving on the right plane, but I can still come inside and outside of here. Get to my Advanced tab. I'm going to go Width. And again, a different menu up top, so you just got to pay attention to what SolidWorks is asking for when you're selecting these mates. So it does try to navigate you along. So my width selection are going to be my outside edges. So for this case, it's going to be here and here. And once I have two selected, you can only have two tabs. So it's always two width selections. So it's going to trigger my tab selections now. I can select here and here. I'm just going to get a better view. You'll notice that I'm perfectly centered now on my track. However, you do have some other options inside your width command. So if I wanted to stay constrained inside of here, but still have the ability to move, I could do a free constraint, and this gives me the ability to slide back and forth now, but I never pass through that wall. Another one is we can drive a dimension, which is really a distance mate, but it is still giving you that constraint of the other edge. So if I come to 0.5, I'm now locked down in this spot, but I know, SolidWorks knows at least, that if I try to go 1, it's going to yell at me saying I can only go up to 2/3 of an inch here. The last one we have is a percentage, which is a bit different than a normal standard distance mate, because I can now say I want to go 50%, which is our middle, so that's going to be the same as centered. But now if I want to go 75%, it can calculate outside edge to outside edge and then put our part at that right distance. I'm going to leave this one at free so I have some motion later on. Hit my green check. And now I can start to see that I am staying inside my track, but I can still cross these two. And that's going to bring up, hopefully, our next one. Yeah, no, I'm going to jump down here and do a distance mate, on an advanced distance mate. So just like before, we have the ability to do distance mates. What makes it advanced here is that we can put limits on it. So this is actually a limit mate. So for this, I want this face to go to this face. So that gets locked down. And my distance to be 0, because I don't want to leave my track ever. Now that's pretty coincident with the edge. The difference now for the distance mate is I have a maximum value. So if I want to go up to 2 inches, I can start to see where my motion is going to lie. Oh, I did the wrong distance, that's why. So now I can start to see my motion, and as I try to drag over here, it cuts me off. So it has a limit switch on the distance. Let me tweak that. I'm going to flip my dimension, and let me try to go to 2.5. So now I'm stuck at the end of my track this way, and as I come closer, I do have this overlap. So I just need to adjust that limit again. Go to 2, accept that, and now we can see that I'm going to stop right before I hit one another, and I have the desired motion for this assembly now. So it took me 3 mates to constrain these rings how I wanted them, but I have pretty complex motion if I'm trying to design any type of sliding assembly. Alrighty. Path mate. So this one, we're defining a vertex point, and we're going to pass it along a detailed path. So we can define some pitch and yaw. I'm going to keep it simple today. Let me close this guy down. Nope, wrong one. This one. I'm going to keep it pretty simple and just show you how a path mate is going to slide on this very complicated roller coaster-like assembly here. So as you can see, my mates over here, I have this guy locked down, and then a width mate just to keep my peg here in between the tracks. So what I need now is, again, in my advanced mate, I need a path mate. And what this asks for is first is going to be a vertex, so a point on one part, and then a path that I want it to follow. So my vertex here is going to be the front edge, and the path that I want it to slide down is the outside edge here. Is it okay? We'll name it front left. That looks good. Now, just got to drag him back into my assembly. All right. So he is currently stuck to this rail, but it kind of defies physics right now. So I can go through here. I can always spin because I'm just locked down on a single vertex. So what I need to do is throw one more mate on here and another path mate, but I'm going to go for the opposite edge. Inside my advanced mates, another path, this vertex, this outside edge, and we'll lock that down. Now we're got back right is our path. Accept that. Bring them in. Not really sure why that occurs for a path mate. It jumps away, but then as soon as you try to move it, it snaps back into play. Now we can see that our motion for this path is always going to follow. And similarly to our width mate, we can define some characteristics inside so we can stop it at a specific distance to our path. So this is a pretty complicated spline. You may not know where 10 inches is to say this is where you stop. So we can define that distance as well as a percentage. So I only want it to go 75% of the path and then stop and come back. we can define that as well. And then our pitch yaw and roll control, we can either let it roam free or we can always follow the path. So pretty cool tool there. Get out of that. All right. Last one I want to show today is this linear coupler mate. So what this is doing is creating a relationship between translation of two components. Got a new demo here, slider. All right. So what I'm looking at now is a three-piece assembly. That guy's fixed. So if you've ever seen a keyboard tray that slides out or a rack-mountable component, you always have a sliding component that will lock into place for a fixture. So right now I have no mates. I need these guys to be all inside one another. So I'm going to use my with mate here to do that. So I do have a couple tabs. I'll select those. Then my outside edges here. That'll link in. And I'll run that one again for this part. Oop. One edge. Let me just make sure I'm still selecting the right things. Another face. And the width is going to require a face. You can't use an edge or a vertex there. That looks good. And I just want to lock these things down with the standard coincident mate. That looks good. One more coincident mate here. All right. So now my assembly is somewhat defined. I have the tracks that I want, but I don't really have the motion that I want yet. So everything is on its own and can leave the track at any time. So not the desired result. What I'm going to use is my advanced mate and its linear coupler. So what this now gives us is a new menu for two options. So I can select two parts here, and it's looking for faces. So it wants to know which faces are moving and how far are they moving. I'm going to select this one and this one. And now, based on these colors, I can give a ratio. So kind of like a gear turning. We can pick, as the red one moves 1 inch, how far is the purple one going to move? So for this case, I want it to move 2 inches. So a 1 to 2 relationship. I can always reverse it, but for this case, I'm going in the right direction. I'm going to hit OK. So now, as I move my outside flange here, you'll notice that my inner one, the black one there, is going twice as fast. And then we run into the issue where it floats. So what I need to do is put a limit on this as well. And we've already showed how to do that. We come in here, we select the two faces that we want to lock down originally. We want them flush, so I'll do 0. And then I can go a maximum, let's put it up to 25, let's say. So now, as I'm coming up this way, I can no longer pull this out any further. I can always retreat back in. And as I can look from the inside, we can see that moving to retract and all end up in the same plane. It's called a linear coupled mate with a limit distance to lock everything down. So the limit mates I showed a couple times in there gives you a min and a max range to keep components restrained to a certain area. Can also work with angles. So if you have a door and you want it to only go open to maybe 120 degrees, you can start it closed, make that your 0 limit, and then go up to 120 degrees. So as you're inside an assembly and trying to swing open a door, it doesn't go 360 and keep spinning and breaking hinges. You can actually control the gap that it's going to open. All right. I mean, that was the gist of today's Lunch and Learn. I do have one question. Profile mates only in 2015. That's when I noticed it. It could be in 2014, but I believe it is a new feature for 2015. I can get back to you on that one, though, Paul. Any other questions coming out of today's mate discussion? All right, I'll go through my wrap-up here. CAD Dimensions does have some upcoming events. Next week, we have a SolidWorks hands-on test drive in our Buffalo office. The next day after, what's the 19th? Wednesday, there's a 3D printing seminar where we're out in the SUNY area in Albany. We're at a hotel right in Albany. Then another SolidWorks test drive in our Syracuse office on Thursday next week. And same day, we have another 3D printing seminar about manufacturing out in our Henrietta office. In case you missed anything, or you want to send this Lunch and Learn to anyone else, you can follow us at information at CAD Dimensions or information.caddimensions.com, and we'll post this to our YouTube channel right when I'm done with this. And we're constantly have new information going out to the blog, so please check that out. The most recent one was how to update your software. So if you ever run into issues while you're updating, Ashley created a very nice tutorial on step-by-step for that. Can we access this recording on your website? Certainly. We have the link to the video on the website. We actually keep I think it's the last 10 recordings on the website, and then everything else is going out to YouTube. We also store these, so if you do have a buffering issue, just request it, and we can send you the file itself. How do you deal with a pathmate allowing to interfere with the path? So that's a great question, actually, and I dealt with it for a bit today. Let me go back to my path. So if your part does interfere, and this is a pretty complicated path here, so what you would end up needing to do, and part of it is my design work here is fairly flawed, that my part is a lot bigger than my pathway. Put that back up here. What it would end up being is some tangency from the bottom of your part to your path. So you can never make them parallel because of the curves, but you can use tangency to keep them on the same plane. But because of the size of my piece here and my path, it was just too wide that my tangency would over-define this relationship, and I would no longer get motion. But for a better designed part and not a sporadic spline, tangency would work for you. All right. How can you do a mate reference on a tapered surface? I guess I'm not clear on that one, John. So if I have, let me just open up a new part real quick. So we had a tapered edge, I guess. Get some draft. Save that. And we'll bring it in. So how do you do a mate reference? Is there a specific mate you're trying to do for this tapered edge? I'm attempting to have a conversation through the questions. Here we go. It would be a distance from one end to the other. From one end. You were trying to create a distance mate from there to there. Yep. For a rounded edge, what you'd end up doing is creating a plane. So if I selected a point where I want a plane, I can do it that way. So let me edit this part. So if you know how you're trying to make this, I can do an edit. And go ahead and throw a reference plane on there, or even a point. So if I know the point that I want to go through is here. Yep, that looks fine. Now I want to do a plane based on this and going up through this edge, which I can't do. A tangent plane running through there. I thought that would work. That's a good question, John. Let me do some digging, and I'll get back to you. So it's a distance made from a tapered edge. Yep, I will respond to you there. Any other questions out there? All right. Thank you for your time, and pretty sure our next Lunch and Learn is about a month away, and the topic is